Welcome to the first higher tier video. I hope you've had time to have a go at this. We're looking at similar shapes. So, question 1. These two shapes are mathematically similar. That means they have the same angles. And one is an enlargement of the other. So, good enlargement, what we want is a scale factor. So we're going to look at the shapes and immediately notice that we've got two corresponding sides there. So we're going to use those two numbers to figure out what the scale factor is. And to turn 6 into 9, pretty straightforward. You can divide that by 2, and that gets you to 3, and then we can times by 3. And we can combine those two things into a single scale factor. Dividing by 2 and timesing by 3 is the same as multiplying by 3 over 2. But you might find it easier just to consider it like it really depends whether you've got a calculator or not. So, calculate the length of BC. So, where's BC? Well, BC is this line here. And you can see it corresponds to this line here on the smaller shape. So that's what we're going to use. We're going to take R8 and we're going to divide it by 2, which gets us to 4, and then we're going to times it by 3, which gets us to 12. So that's 12 centimeters. Calculate the length of EF. So EF, there's EF, and it corresponds to this side on the shape. You can see this is the same thing, just backwards. So we're starting with our 7.5. We're going to go backwards. So 7.5, and this time we're dividing by the 3, which gets us to 2.5, and then 2.5 multiplied by 2 gets us to 5. So that's 5 centimeters. Question 2. Here is a photograph. What a lovely photograph that is. But everyone wishes they had a car like that. So the width of the photograph is 6 centimeters and the height is 3.5. So I'm tempted to write that on really. So that's 6 centimeters and that's 3.5 centimeters. And the photo is going to be enlarged. So again, I'm going to draw myself a big photo. There's the big photo. And there's the big car here. I'm sorry, did I draw a tractor? Never mind. Okay, there we go. There's a tractor, the big car. Now, the photo is going to be enlarged. The new width is 7.5. So we know that the new width is 7.5. And you can see here what they've done. They've given us two corresponding sides so that we can work out a scale factor. How do we turn 6 into 7.5? Very straightforward to work that out. 7.5 divided by 6, which gives us 1.25. So the scale factor is 1.25. So all we have to do now is take our 3.5, multiply it by our scale factor of 1.25 to get our new length, which is 4.375. 4 3/8. That's the new height there. And that's the answer. And I just put the units on because they've not written them down. Question 3. Diagram not accurately drawn. Thanks for that. Now, notice we've actually got several triangles here. We've got a little triangle like this, and then we've got a bigger triangle like that, and then we've got another one over here. Now, the important thing to notice to solve this problem is that all of those triangles are similar. Why is that? Well, these two angles are equal because they're opposite. So this triangle here and this triangle share an angle. This angle here is the same as this angle here. They are corresponding. And it's also the same as this angle here. So I suppose I should probably make that like that. So those three angles are the same. And because they're all triangles and they add up to 180 degrees, the third angle must also be the same in each triangle. So we've got three triangles So triangles are all similar. And what does that mean? It means that they are enlargements of each other. So let's see if we can figure out some of these missing sides. So let's go for the x first of all. So I'm going to use the small triangle here. There's the small one. That's the 5 and the 4 triangle. And I'm going to consider this one here, the ACB triangle. That's my next. And I can see the top of this one is 4 and 2. That's going to be 6. And I don't know how long the bottom is. But that doesn't matter because I've got 2 corresponding sides. So to get from there to there, I divide by 2 times by 3. So divide by 2 times by 3 gets us to 7.5. So this length here is 7.5, which means that x has got to be 2.5. So that's the first one. Now for the one over here. Well, it's a similar triangle, it's upside down. That doesn't matter, it doesn't stop it being similar. And I can see the 6 is the side that corresponds to the 9. So I need a scale factor here, and that is divide by 2 and times by 3. Bit boring, isn't it? So to get y, I'm going to do that to the 7.5, the long side on the bottom. So I do 7.5 divided by 2 gets me 3.75, and 3.75 times by 3, which gets me to 11.25, which makes me just wonder. No, that's fine. Right. Now, the one you've all been waiting for. Who's had a go at this now, and who's just thought, well, I'll wait until Mr. Greaves does it later. Well, if you had a go at this one, well done. I hope you had fun with it. So we've got a frustum here with a hole in the middle. So a frustum is the light shade, the lampshade shape. So first of all, we're going to work out the volume of the frustum. So we'll go down to here. So the volume of the frustum is going to be pi times h, which is 21, divided by 3, and then r. So if we go up to here, r is the radius of the base, and the radius of the base is 40, so it's 40 squared plus little r, and little r is the radius of the top, which is 20, and that's times big R, which is 40, and it's plus r squared, little r squared, which is 20 squared. So if you're not sure where I got that from, all I've done is I've taken this formula here, and I've taken h, which is the height, I've taken big R, which is the radius of the base, which is there, and I've taken little r, which is the radius of the top. I suppose I should put that in there. So that's all I've done there. I've just substituted in, and you can see how that works out down here as well. In fact, it's something you may want to consider doing yourself if you have trouble keeping these things straight in your mind. And now I'm just going to type it into my calculator, the trusty FX83 GT Plus, and I'm going to type it in, and it's going to look exactly like that. So here we go, 40 squared plus 20 times 40 plus 20 squared. Hit the equal button and I get the grand total of. Now I'm going to write down what it says on my calculator, which is 19600 pi. And the reason I'm not turning to a decimal now is because this is a more accurate number. Now that's the frustum. Now we need the hole, so the cylinder. And the volume of a cylinder is pi r squared h. So let's just substitute into that. So it's pi times, now the radius of the cylinder, well, 20 across the radius is 10. 10 squared times 21, that's the height. And that gives me, I'll pop that into the calculator, pi times 10 squared times 21, and that gives me 2100 pi. Now, the volume of the model of the volcano is the volume of the frustum minus the volume of the big hole down the middle of the frustum, which is going to give us 19600 minus 2100, so 17500 pi, and that is the volume of the model. Now, if only that were it, because that's the volume of the model, but actually the question wants the volume of the real volcano. So we've got to use the scale which they give us here, so 1 to 10,000. So I'm going to run out of room here. So 1 to 10,000 is telling us that the length scale factor is 10,000, so multiplied by 10,000. But what we want is the volume scale factor. So to get that, we've got to cube the length scale factor, which gives us a very big number indeed. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's put some commas in so we can see it better. And that is a million million, or 1,000, 1,000, 1,000, 1,000, or it's going to be one of the billions. There are a couple of definitions of that. So, we take our volume of volcano, the model, which is that many cubic centimeters, and we multiply it by the volume scale factor. 5, 6, 7, 8, 9, 10, 11, 12, and we get 17500, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi. Lovely. Put off yet? And that's also cubic centimeters. Now, it'll help a lot if we can turn this into meters. So, the question is how many cubic centimeters in a meter, and it's not 100. So 1 cubic meter is 100 cubic centimeters. And if you're not sure about that, just consider a cube that is 1 meter cube even. That's 100 centimeters, 100 centimeters, and that would be 100 in the bottom as well. And you can see that 100 times 100 times 100 gives you the volume. So that is that's how you convert cubic centimeters to cubic meters. You divide it by a million. So I'm going to do that here. Tell this answer has been carefully planned. So I'm going to have 175, and I'm going to lose 1, 2, 3, 4, 5, 6. So I'm going to be left with 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And now it's in cubic meters. That's a lot of cubic meters, and I've forgotten the pi as well, haven't I? So let's actually just multiply that by pi. So 1750, 1, 2, 3, 4, 5, 6, 7 times pi, and that gets me some repulsive number, which is 5.498 times 10 to the power of 10. Now, what do they want from me? Well, as to be said, that looks like a reasonable answer to give. Certainly, we should probably have retreated to standard form earlier. And we'll stick that there. So, can we even say that? What a huge number. I hope you've enjoyed doing it, and I'll speak to you tomorrow.